Hello, I am Brian Corbridge, and this is my lab for the second part of charge tape, which is the second lab for Physics 2212. This lab, we're going to be using the same setup and same data as the first one. Everything's the same, except now we are going to be treating the piece of tape as a line charge, distributed charge, that is, instead of just a singular point charge. From the last lab, we found the charge of one piece of tape to be uh, this number right here, 1.167 times 10 to the negative 8 coulombs. This time around, treating the tape as a line model, I found the electric charge to be 2.37 times 10 to the negative 8 coulombs. The fundamentals that we're going to be using for this lab is going to be the exact same ones as the last lab, which are the Coulomb's law, we have Newton's second law, and then we have the gravitational force equation. We used those same ones last lab, except now we're going to be adding uh, the electric field of a distributed charge, which is a summation of all the charges if you were to divide the piece of tape into many different point charges. So that's going to be the only fundamental difference this time around. Here's the code I put through GlowScript to calculate that electric charge for this part of the lab. Our physical constraints are the same as last time. This bit was what was calculated for the charge of one piece of tape from the last lab. As we work our way through the code, we see this part right here is just that Coulomb's law from last slide. This is just setting up the different point charges that make up the entirety of the tape. This is more of that. I put the starting position as negative 0.1 just because it centers it on the picture you're going to see on the next slide. If I kept it at 0, it was going to be like just shifted to the right. It doesn't really do anything. It just is there for artistic purposes. Same thing with this E scale right here. As we keep going, we see this bit right here is just calculating all the interactions between all different point charges, and that's going to give us our green arrows that you're going to see on next slide. And yeah, and then here are the arrows. Just a little key before we go to the next one. The white arrow is going to be the force, the net electric force vector, and then the green arrow starting in green. The yellow arrow going down will be the gravitational force vector. Here you can see what I was talking about on that last slide. These green arrows are all of the electric charges of these point particles that you can see make up the top piece of tape, these red dots, and then the bottom piece of tape are these blue dots. Yeah, this white arrow is the net electric charge, which is a summation of all of these. And then this yellow arrow, like I said, is the gravitational force going down. This gives us the magnitude of the electric force to be this 2.37 times 10 to the negative third. That's going to be this white arrow, and then magnitude of gravitational force. As expected, pretty similar is going to be this number right here. For this lab to be useful and not overbearing, we had to assume a few things. Um, a lot of these assumptions are the same from last lab, such as negating air resistance and also keeping in mind that all of the data we have, like the mass of the tape and the exact length, these aren't exact measurements. We're doing our best to be as close as possible, but we don't have perfect numbers. But a possible error that's really important that we need to think of, we can't really account for it, like I said, but we do need to remember that during this lab, the tape will interact with other charges, not being the other piece of tape. And that is going to skew the results a little bit. And we do try our best to minimize these effects, but at some point, it is out of our control. So we just kind of have to live with that. To wrap things up, just want to go over some common questions. What if we modeled each tape as a single point charge? Uh, so that's just gonna give us what we got in the last lab, which was nearly half of what we got in this lab. In fact, I believe it's actually a little bit less than half. Um, and these are different because we're treating the line as a summation of a bunch of different point particles. And so if it was just a single point particle, it would be a summation of just one thing, and it's gonna give us what we got last time. And so it's gonna be different than what we got this time.